If we had a rectangle that was 6 centimeters by 7 centimeters, we would say that its area is 42 units squared. If we had a rectangle that was 20 centimeters by 7 centimeters, we would say that its area is 140 centimeters squared. This rectangle is a square which is 1 inch wide and 1 inch tall. So it has an area of 1 inch squared. If we had a rectangle that we knew was 1 inch wide, but we didn't know how tall it was, we could say that it had a height of x. And we would write it like this. Its area would be 1 times x, so x units squared. If we had a different rectangle that was a width of 1 and a height of y, because we didn't know how tall it was, we would say that it has an area of y units squared. If we had a rectangle that was a width of 1 unit and a height of b units, because we didn't know how tall it was, but it was a different length than our other rectangles, so we called it b, we would say it has an area of b units squared. And if we had one more rectangle that was a height of a and a width of 1, we would say that it has an area of a units squared. If we had a shape that had a height of y and a width of y, it's y by y, so it's y units squared. A shape that is x units wide and y units tall has an area of xy. Again, if we had two lengths that were the same, b times b, we would have an area of b squared. And finally, if we had a shape that had a height and a width and a length, all the same x, we would have x by x by x, x to the exponent 3, x cubed. These geometric models help us to see that when we're multiplying powers that have the same base, we add the exponents. So m times m would equal m squared. X to the 2 times x to the 1 would equal x to the 3. Y to the 1 times y to the 4 would equal y to the 5. B times A is just BA. But B times A times B would be b squared a, or a b squared.